in the last 40 years, and David certainly knows more about the last 40 years of this than I do, but what I've learned in the last 2 years is that there's 40 years of recent scientific literature which shows that, for example, one thing people may not realize is that every cell in your body pretty much has something called a vitamin D receptor.
Travelling to a game either at Anfield or maybe following the Reds away from home. There's a good chance you'll be connecting to public Wi-Fi somewhere along the way. But did you know that the free Wi-Fi is the hacker's favourite pitch? So instead of chasing the ball, they're ready to steal your sensitive information.
And that's unique to vitamin D. That's not true of other vitamins, and it's not true of other nutrients. There is a receptor on cell surfaces which is a vitamin D receptor, and vitamin D gets taken into your cells, and it modulates thousands of genes. So more than 20,000 genes have been identified now that are involved in some way. So we're still really at the very beginning of discovering how vitamin D works and what it does in the body. But there are certain biochemical pathways that are extremely well understood. For example, there's a part of the body's response to infection is controlled by something called the renin-angiotensin system, or the RAS. And the RAS is it's responsible for controlling blood pressure, for one thing, and it's also responsible for your inflammatory response to pathogens, diseases, viruses, bacteria. And the RAS is quite a complicated biochemical system, but it's fairly well understood. And vitamin D controls something fundamental in that system. It controls the renin gene expression, which is something that happens. So to use lay terms, the RAS is a bit like an engine which has an accelerator and a brake. And when the accelerator is being depressed, your immune response and your blood pressure start to go up. And because that's happening, the brake also starts to be depressed so that the engine doesn't go out of control. And a certain recent event has highlighted the importance of something called ACE2, which am I allowed to say that without?
I think you're allowed to say ACE2. I think there's a certain viral condition for viral conditions.
That's correct. Yeah,
produces a cytokine storm and overreaction by the immune system.
So well-known virus latches onto ACE2 receptors on the cell, and ACE2 is effectively the brake. So when you have a lot of ACE2, it calms the RAS down because it breaks down something called angiotensin 2 and starts it on its metabolic pathway out of the system. And in the normal, what's called the basal state of the RAS, ACE2 binds with another membrane receptor called ATR1, and effectively ACE2 is hidden. So in your normal state, you have lots of ACE2 on the surface of your cells, but it's masked from visibility, and so that it doesn't enzymatically clear away things that it's not ready to. And as your RAS gets activated, the accelerator gets pressed, these two membrane proteins come apart, and ACE2 starts doing its work as an enzyme and keeping things under control. And when you're infected by a certain well-known virus, your ACE2 levels rapidly deplete because the virus enters the cells via ACE2. Your ACE2 levels plummet, and it breaks the brake. So you end up with a machine, an engine, which has only an accelerator, and it's designed to have an accelerator that's tampered by a brake. And if the brake is broken, the accelerator goes out of control. And the engine goes out of control. And that's what we know as the cytokine storm. This mechanism is really well understood, actually. It's not very well understood by many people. That particular mechanism is something that's only recently appeared in the literature. I noticed it in spring, and it's only one mechanism. There are dozens of mechanisms that we know, for example, that vitamin D controls production of things called AMPs or CAMPs, and one of those, they're antimicrobial peptides, and the one particular one, for example, is called cathelicidin, and it's, if you've got plenty of, is that how you pronounce it, David? I'm not.
Cathelicidin.
Cathelicidin. So I'm always worried because I learn things from books. I sometimes pronounce them, and doctors look at me strangely because I didn't go to med school. I'm a physicist, not a medic. Cathelicidin, is it?
Yeah. Something like that. Siding at the end.
Right, of course, because it kills things, right? Cathelicidin generally deactivates microbes, whether bacteria or viruses, and vitamin D is involved in the production of cathelicidin. So, there are many. I mean, I'll give you an example of how.
Hold on.
This is known as the Blue Book on vitamin D. It's 2,500 pages of scientific literature on. This is just one technical set of books on vitamin D. There are many, many more of those. And if you go on Google Scholar and type vitamin D, you'll come up with literally hundreds of thousands of papers that have been published in the last 40 years. And most of it is not known by doctors. So
Could I follow on from that?
Please
You
do,
mentioned the last 40 years, Gruff, and you're absolutely spot on. It was about 1980, the first papers released on vitamin D and the immune functions. Although it's been known for a long time that sunshine cures or resolves tuberculosis in particular. Anyway, but those 40 years, that I would imagine that 95% of doctors have nowhere near your knowledge of vitamin D and its activities on other than bone and the prevention of rickets. There's no idea of the immune function. The ignorance of the doctors is not, it's not their fault. They were never taught it. It's never come through to them.
And they never have time to catch up on the literature.
That's right. And at the top of medicine, there's a surprising lack of curiosity about it.
Yeah.
Because so much has been discovered or has been noticed during the past year.
Yeah.
But people are not learning from the experiences of the past year, unfortunately. There's a lack of curiosity.
There's a resistance to wanting to know about it, isn't there? Which we've noticed a lot of. And I think some of that I'm beginning to understand is because in the 70s and 80s, there was for some reason, I mean, the origin of medicine was nutrition. So, Captain Lind discovered vitamin C by doing, one of the world's first clinical trials. He took 6 sailors and fed them oranges and lemons, and took 6 sailors and gave them a typical sort of ship diet. And those 6 got scurvy, and the 6 that were given oranges and lemons didn't. And the effect was very large. So you could do it with a small number of people. But for some reason, nutrition, I think, got relegated to nutrition rather than medical well-being, and it stopped being medical at some point in the 20th century. And because I think in the 70s and 80s there was a lot of research around nutrients and around things like fish oil, but they were really badly run studies. They barely deserved the name study. Actually, they didn't have control groups. They were just, like, one famous study I think in Dartmouth was done with fish oil, and it was given to school children, but there was no control group. And the press got hold of it and they published it saying it increased exam results, and it was basically not, I mean, who knows what benefits actually happened, because the study was so badly designed, it couldn't claim the things that it was claiming. And I think what's happened is there's sort of been an overreaction, or almost an overcorrection, because there was so much bad nutritional research. Food science got a bad rap, and we're suffering that now. That and the fact that vitamin D was mislabeled a vitamin meant that a lot of people sort of automatically park it in a sort of quack science or stuff that you should really trust. And it's very, very hard now to get people to take it seriously. Even though
let me come back on some of the stuff that you both said, right? Yeah. So one is, I think there's certainly a pull, or we're into this for many, many years now, this pharmaceutical corridor, because that's where the money is. There's no money to be made from recommending sunshine to people.
Or vitamin D supplements. I mean, pharma
supplements. You can't patent sunshine or Bangladeshi fish. Right? So there's no money in that, and then all the research grants and the universities and the institutions that do all this research, nobody funds them to research the effects of Bangladeshi fish or sunshine or whatever, right? Because there's no money in it. So that's one. Then I wanted to go back to what you said earlier on about. So let me get this right. So every cell in the body has a receptor for vitamin D.
Yeah. And
vitamin D is a very, very old nutrient, 2 billion years old.
Yeah.
So every cell in the body has a receptor for vitamin D. It modulates the activity of over 20,000 genes in human beings.
At least, I mean, that's
at least, okay.
So far.
Which means that without vitamin D, then that act of modulating of how these genes should operate is going to be impaired, which I suppose could lead to a whole range of poor health outcomes, and it does, which is why vitamin D seems to be so effective in all sorts of issues, because when it's not there, it can't do anything. And then when people are infected by something that may lead to a cytokine storm, then having vitamin D means that the brakes work effectively, because they're not being disabled by this particular topical virus.
And it's important. Some people have criticised it, saying that vitamin D is touted as a silver bullet or a panacea. And I mean, you can nitpick those terms and say, well, it's not a panacea. It doesn't cure everything. That's true. It's not a silver bullet, but it's as close to those two things as I know any other thing is. It's like wearing a bulletproof vest. It doesn't
stop. Another way of looking at it. Vitamin D is not a silver bullet. It's not a panacea, but neither's water.
No.
But water is essential for metabolic processes.
And if you're dying of dehydration, then water is quite a useful thing to have. I think of it as it's like a bulletproof vest, right? It's not going to stop a bullet to the head.
Neither's water.
It's not a guarantee. But if you're in a battle, you want to be wearing a bulletproof vest.
Yeah. You want to give every single cell in your body enough of this compound that it needs so it can work effectively. Yeah. But the problem with this compound, and I've been told this many, many times by medical professionals, is it's very, very dangerous if you have too much. Never mind ibuprofen.
Yeah.
Never mind all the other pharmaceuticals that doctors prescribe, aspirin causing intestinal bleeding at a subclinical level, right? Ibuprofen not being good for your liver. Never mind all that. And then you go to the extremes like thalidomide. Vitamin D, if you have too much, it's very dangerous. It's toxic. So what levels are toxic? What is this nonsense about toxicity? How much do you guys take? And then I'll share how much we take.
If you go out in the sun for 10 minutes, you immediately die of vitamin D toxicity. This
really?
is why people no longer go on holiday, because
oh my God,
the sun is so...
I spend hours in the sun in the summer.
Maybe in half an hour of full sunlight, I think you can produce between 10 and 20,000 international units of vitamin D in your skin. And that's just half an hour of full body.
That's you, Gruff.
Yes, you couldn't, clearly. I mean, but David and I probably would produce that amount. And obviously I would die immediately of vitamin D toxicity because it's terrible stuff.
The point is, it is impossible to have vitamin D toxicity from the sun. Because as the blood circulates through the skin, any excess vitamin D is destroyed by the action of ultraviolet light on vitamin D itself as it's recirculated. It's impossible to get vitamin D toxicity from the sun.
Yeah.
Full stop.
You reach a level of homeostasis where the vitamin D starts to get converted back.
That's right. Yeah. Now, when during this year, if we've had sort of 4 million people dying from a viral infection, well, no, not 4 million, 4 million cases. What is it 2 million or 4 million?
1.5 million, I think now, is it?
2 million, I can't quite remember now. I only look at the number of deaths.
Well, in Britain, it's about 85,000 or something like that.
Okay, we'll say
with a viral infection, provided they tested positive within 28 days of death.
Well, say there were 1 million people with a virus infection and 120,000 died. How many cases were there of vitamin D toxicity? I've not heard of a single one.
I don't think a single one has been reported.
I would think not a single one, to be quite honest. It is that rare.
And there probably haven't been in the last decade. It's incredibly rare.
I'm sure that's right.
But there's a lot of noise about it, and I think it is because there's no money in vitamin D.
Well, a lot of noise comes from empty vessels. Empty vessels make most noise. You can tell that as our little boy. And it's true. The ignorance. And the people who are ignorant are the ones that do the most talking about the subject. It's just so frustrating,
As my grandmother used to say, knowledge is like jam. The less you have, the more you spread it around.
Okay, very good. So how much do you take? How much do you recommend? What should somebody do if they're interested in it? Depending upon their age, the color of their skin.
Well, it doesn't matter what the color of your skin is or how old you are. You still need the same amount of vitamin D as somebody who is young with a white skin if you're not getting enough of it.
Right.
And the standard recommendation is somewhere around about 3,000 or 4,000 units per day. I take 20,000 units once a week, which is the same as 3,000 units a day, and that gives me a very, very good blood level of vitamin D. And that's what we need to do. We need to check our blood levels. That's the important thing. We need to know what we're in. We're trying to correct a deficiency of vitamin D.
So I started taking vitamin D because I was diagnosed as vitamin D deficient, and I was told to take 2,000 units a day to correct that deficiency. But the more research I did,
what was your level when you were diagnosed?
I can't actually remember, but I'll need to go and look it up. But I was technically deficient, and the level, the British definition of vitamin D deficiency, I believe, is 25 nanomoles per litre. So I must have been less than that.
25 nanomoles per
10
milliliter.
nanograms.
Which is 10 nanograms. So I was around the sort of level of deficiency that David was seeing in his community in the north, which is, dangerously low. Otherwise, it wouldn't have come up. It was on a routine blood test, and so I started doing some research into it. And because of what I discovered, I decided to take 4,000 units, more, which is twice as much as I was advised to take. And I tested my levels about 6 months ago. And after a year and a half of this, I didn't even get to sufficiency. So I got to 70 nanomoles per litre. So whatever it was that was causing me to be deficient in the first place meant that I needed more than the typical amount. So 3,000 as David takes wasn't going to get me to my level, and certainly 4,000 didn't. And I think it's possibly because I've got some gut absorption problems, which are very common. It's fat soluble, and it has to be absorbed in the gut, and maybe that's why that's happening. My mum, it might be genetic. My mum tested recently, and she's been taking 4,000 as well, and gets plenty of summer sun. And she had almost exactly the same level. The test that we did, her level came out, I think, 0.2 nanomoles per litre different to my original value, which is
it will be genetic, but
right.
It will be genetic, not malabsorption.
Right.
But what it is, the vitamin D is carried around in the blood in something called D-binding protein.
Right.
And the amount of vitamin D binding protein in the blood is determined genetically.
Right.
And so you've obviously not got very much in your family.
Yeah.
So
I got
you
my brother to take
blood
it.
level.
Well,
yeah.
He definitely should be taking. Well, he is taking some because of me.
Yeah.
So I've increased my dose. I increased to 10,000 units a day, and I did that for the last 3 months, and I've just brought it down again because I've been doing 10,000 for 3 months. We generally advise people. There's a community of scientists and doctors who've got together to do this open letter to advise people, and we advise people if they haven't started supplementing and they're just starting now and they're in winter, to do a couple of weeks of 10,000 as what's called a loading dose to get the levels up, and then go down to between 2,000 and 4,000. So there are certain conditions that suggest you should take more than the average. So if you're particularly overweight, because vitamin D is fat soluble, it'll be distributed through your body weight. So you should probably take more if you're overweight, and you can actually calculate how much you should be taking by weight. There's an American charity called Grassroots Health. You've got a calculator. It's worth Googling to find that out.
But that's fairly easy because we're talking about 1 unit of vitamin D, and 1 unit is the daily requirement of a 10-gram immature mouse.
Right.
That's my definition. Because there was a time when vitamin D couldn't be measured in a physical sense. It had to be calculated for what was required for a mouse.
Right.
In the laboratory. So that's what 1 unit is. So 1 unit is the requirement for 10 grams. So
Right.
you multiply it up. So if you weigh 60 kilograms, then on that calculation you need 6,000 units a day.
Right. Right.
Most
people are taking far less than that.
Yeah,
so,
that's right.
I want to say
the blanket advice for anyone, if you don't want to do any calculations or tests, is take 4,000 over winter, 4,000 units a day. You definitely won't be in danger of vitamin T toxicity unless you have a couple of preconditions. One's called sarcoidosis, and I should really defer to David again here as the doctor.
Staggeringly rare.
Very rare condition called sarcoidosis, hyperparathyroidism, and these are conditions which, if you've got them, you almost certainly know already, or you'll find out pretty quickly. But for healthy individuals, adults or children of adult weight, 4,000 units is way, way below a level which could possibly cause vitamin D toxicity.
The point is, though, blood testing should be done to check the vitamin D level and the calcium level. And it's like if you have diabetes, you don't just take a bit of insulin, so this will do, and you make sure you get your blood sugar tested, your HbA1c tested. If you're on thyroid replacement therapy, you get your blood thyroid levels tested as well. And it's just the same with vitamin D. It's a deficiency state, and we've got to have appropriate blood tests. You know, we're not living in the 1920s.
No.
We're living in the 2020s.
And most doctors will refuse to test vitamin D if asked. I think you can pressure them if you really want to, if you don't have money, or you can buy your own. Like, you can buy online tests and send them off to a lab. There are finger prick tests where you drop a bit of blood onto a spot of special paper and send it off to the lab, and they'll tell you what your levels are. I've done that twice now. I'm planning to do it again.
But you see, I checked the blood on 2,500 people during my research, and It's not expensive, actually. So
Right.
it isn't. If
It's an
you get someone
excuse.
else to do it, it's expensive. If you do it yourself in-house in the hospital, laboratory, you buy the kit, and after that, it's just reagent cost.
Yeah.
Not expensive at all.
Right. So we need to
I had
educate
that.
people around expense as well.
Yeah,
Doctors.
but if I can say, so I had that. So a couple of years ago, so at the end of one summer, I think it was September or something, 2019. I said to my GP, I want a blood test for my vitamin D levels, and she said to me, "We don't do them." And I said, "Why?" She said, "Well, we just assume that everybody's deficient." And I said, "Look, I'm dark skinned. I'm dark skinned. I want to know where it's at." So you're right. I did have to pressure my GP because they said no, and then they said, "Okay, no problem." They gave me the test, and I got the results. And then the surgery rang me and they said, "The doctor says you've got to stop taking the supplements. Your levels are too high." And they were 150 nanomoles per milliliter.
Yeah.
And I said to the receptionist, I said, "Okay, all right, thank you." I hadn't taken any supplements since March, that spring, all from sunshine.
Yeah. And we know now those levels are optimal. So
Because I've looked at some stuff, some
are out of date, and unfortunately, NICE, the National Institute for Clinical Excellence, keeps telling people that you have to only take 400 units a day, which is 10 times too little. It's insane.
I'm taking 100,000 units a week. I do take it with vitamin K2 because that helps drive it to where it needs to go in the body.
That's correct. Yeah.
And you know, I'm in good health, but then also, what was I going to say about the? It's just gone out of my mind. I need to take more vitamin D.
Well, vitamin D deficiency is definitely involved in dementia. I've been giving it to my elderly neighbour. He got a urinary tract infection, and unfortunately, it exacerbates any pre-existing dementia. He didn't really have obvious dementia until he got this UTI. He's 90. He's just turned 94, and poor guy's been in and out of hospital. I think maybe 6 times in the last 2 years, maybe more. So across the terrible situation, he's absolutely fine. Hasn't contracted a specific virus that we all know is worrying people.
Yes.
And I was encouraging him to take it to help with his dementia, because it's implicated in brain health as well.
Yeah.
So
it's interesting to think about why people die these days. And the major causes of death are infections, cancer, and old age. Now, I've said infections and cancer, but throughout the world, half of all cancer cases are due to infections causing the cancers, viruses causing cancers.
Right.
And we're likely to find many more. But this is where the vitamin D comes in. If we can suppress infection deaths, we're going a long way to solving problems of premature death. And if we're going to reduce cancer deaths, the same. And there's a lot of evidence supporting vitamin D deficiency and cancer deaths. The benefit of vitamin D on cancer.
And it's been proven with colorectal cancer. We know that it's causally. It hasn't been proven causally with all cancers, but it has been with colorectal cancer.
Yeah, and breast cancer.
And breast cancer as well.
And blood cancer. Yeah.
Yeah.
But
Okay,
you know, we're well on the way then. What it means is we'll all die from old age, because we won't go on forever. We will all die at the age of 100 plus or minus 15 years.
but with our memory intact, without diabetes or dying of heart disease, because I know vitamin D is involved in insulin regulation.
Yeah.
Pretty much involved in everything. I remember what I was going to say. I found a couple of studies or a couple of articles about studies done with modern day hunter-gatherers. And their blood levels, their blood serum levels are between 150 to 200.
Yeah.
I'm low with my 100.
And the other thing is, I think people assume that blood serum levels go up linearly with ingested dose, and that's just not true. So the more it starts to taper off, the more you take, your body learns to metabolize it and keep it under control. It's tightly regulated in terms of the homeostatic balance. So it really is very hard. I know of one case of hypercalcemia in a guy that he was taking, I think, up to 12,000 units a day in summer and sunbathing 8 hours a day as well for 2 weeks.
Oh, wow.
So he was getting a huge amount from sunbathing. And on top of that, he was taking it in his diet at 12,000. But that's one case. If you look at the studies around vitamin D, there are no clinical trials that demonstrate toxicity below, I think, 30,000 international units a day, taken for years at a time. There are cases of people, I think, around 20,000, but again, it's one of those combination cases where there was a natural excess as well as a regular daily amount. They're usually accidents. And there was one case of over-fortification of milk that happened a long, long time ago where they accidentally over-fortified the milk. And the other case I know was somebody was using a powdered form and took a teaspoon and accidentally ingested 1 million units. And they were in and out of hospital in 2 days. It is serious if it's accrued over a long time, but it's fairly treatable.
You stop taking it and the body uses it up.
One way it can come about is that when we're talking about units, well, these days it's possible to measure the weight of vitamin D. And 4,000 units equals 100 micrograms. Now, not many people know what a microgram is. Incidentally, 1 unit is 12 billionths of a gram. So it's only a tiny amount. But if we go back to 4,000 units, which is 100 micrograms, 100 millionths of a gram, not many people outside science have ever heard of micrograms. They don't occur in normal life, and people don't recognize the symbols, and they assume it's milligrams. Yeah. In fact, the Daily Mail did this a few months ago.
Yeah.
You wrote 100 milligrams, when it should be 100 micrograms.
And that's 1,000.
Now, if you take 100 milligrams of vitamin D, you're not taking 4,000 units a day, you're taking 4 million units a day.
Yeah.
And that's asking for trouble.
Wow.
So I think we should all talk in units and not mess around with micrograms.
Yeah.
Too dangerous.
Yeah.
Okay. So what are the different forms of vitamin D and where does it come from?
Vitamin D can only be made from an oil called 7-DHC, the long 7-dehydrocholesterol. And this ultraviolet light breaks one single intramolecular bond to form something called cholecalciferol. Now, whether that's made in the sun or in plankton, and whether it gets into the mouth, through the mouth or from the skin, it has to go to the liver. And in the liver, it has an OH, a hydroxyl group added, and it then becomes 25-OHD, otherwise known as calcifediol, or even calcidiol. And that is the form in which it's measured in the blood. So when it comes to the skin and the blood, when it comes to the mouth, it goes to the liver and it sits in the liver and it's gradually converted into calcifediol, 25-OHD. Now that's its reservoir, but when it's used, it's taken into the immune cells and it's then fully activated into something that's called 125-OHD, also known as calcitriol. And it's in that form that interacts with VDR and activates genes within the cells.
Right. And is that form, is that available, the calcitriol, if people want to get that?
Yes, but don't. Because the cells are perfectly capable of making it. It is used very rarely in very specific advanced kidney disease.
Right.
But generally speaking, don't use the calcitriol. It's made within the cells. What we need is a circulating form of vitamin D, calcidiol or calcifediol. Now that can be given by mouth with very, very dramatic benefits in virus pneumonia, when it reduces intensive care need and increases deaths very, very dramatically. The point is that if we take vitamin D by mouth, it takes about 2 weeks to become fully active.
Yeah.
But if we take the active form by mouth, it takes 2 hours to become fully active to get into the blood. So if you've got pneumonia, it's no good your doctor saying, well, you need an antibiotic, and I'm going to give it to you in 2 weeks' time. If you need the antibiotic, you need it now. And if you need vitamin D to improve your immunity, when you're severely ill with viral pneumonia, you need it in a form that is active in 2 hours as calcifediol, not ordinary vitamin D, which takes 2 weeks.
And is calcifediol available? Easily available if people want? I mean, can they buy it as a supplement?
The answer is yes and no. Most of the vitamin calcifediol, the active form, is actually used in cattle feed because we look after our cattle more than we look after our humankind. But calcifediol is readily available across the counter in Spain, Italy, and Portugal. And I have some from Spain, which I got from Spain. But it's not generally available in this country, even though it is of immense importance in virus pneumonia. The strange thing about vitamin D is I've often wondered how furry animals get vitamin D if they're covered in fur. Now, it's easy for fish to eat plankton, and it's quite easy for carnivorous animals because they eat little animals, which are usually vegetarian. Now, vegetarian animals, they actually produce vitamin, they produce this oil, 7-DHC. We'll take sheep, for example. So the sheep produce this oil, and oils are very important in sheep wool. But that oil is converted into vitamin D. And when animals lick each other or themselves, that's how they take in vitamin D into the bodies from the skin. It's a strange thing. Now, when we take vitamin D supplements by mouth, they come from sheep's wool. And this happens in New Zealand and Australia. When the sheep are sheared or shorn, whichever word you want to use, the oil is extracted from the skin in a solvent, toluene or xylene or something like that, and it's then put in bottles or containers, and it's taken to China, where it's exposed to ultraviolet light to make sure it's converted into vitamin D, and then it is extracted. Vitamin D is extracted and put into capsules, and that's what we take. So we take vitamin D by mouth, which came from sheep's wool, almost entirely in Australia and New Zealand.
Oh wow! And was metabolized by the Chinese sun or Chinese UV, if not the sunlight. Chinese UVB.
But about 80% of world production of vitamin D goes into animal feed, because most cattle now are brought up or reared inside great big barns, shippoons, what they're called. So they don't go outside into the sun. So the vets know very well that the cattle become vitamin D deficient, and so they give them vitamin D. The vets are well ahead of the doctors, I must say. So most vitamin D and calcium goes into animal feed.
Yeah. Okay, so the takeaway is get your blood levels checked, and then take a sufficient amount and have your blood levels checked regularly, and keep taking it because it's really good for your general health. And it's also very, very good to deal with a particular respiratory infection that is the talk of the town. Everybody's talking about it, except there are limits and constraints on what we can say about it on YouTube. So the next part of the conversation will be on BitTube.tv and Bitchute. So I invite you, if you're watching this on YouTube, to go over to my channels on BitTube.tv or Bitchute, and you can find the rest of the conversation. We'll talk about how vitamin D can make a difference to this rather topical issue.